Right here we have Unit 5, Lesson 4 homework, looking at patterns and rules. Okay, so number 1, complete the table for each sequence of matchstick shapes. Use the function rule for finding the matchsticks needed for each shape, including the 50th shape. So we have 1 through 10, and then we have 50, so it will skip quite a bit there. So the first thing we need to do is find the rule here, like what is happening from each shape number. Shape number is the same thing as figure number, which is what we've kind of been, the wording that we've kind of used. Okay, so figure number 1, figure number 2, all that kind of stuff. So figure number seems to always be increasing by 1. So that is a constant change for the figure number. And then number of matchsticks seems to always be including or changing by +3. All right, so we have our rule, our +3. We're always adding 3, so let's continue. 16 plus 3 is going to be 19. 19 plus 3 will give us 21. Plus 3 will give us 24, then 27, then 30. We're not going to fill this one out just yet because we need to know our rule first. Okay, so it's going to be number of matchsticks equals our figure number, our shape number, times 3. Okay, because we're always adding 3. And then that +1 kind of seems like it's random, but it's actually coming from back here. If we did figure 0, that'll give us the starting point. Okay, and if we're adding 3, we got to think, okay, what number +3 is going to give me 4? It'll be 1. So that's how they got that 1, because it is our starting point when we have figure 0. Remember, we cannot figure out the starting point without figure 0. So you always have to find figure 0. All right, number 2, our figure number, our shape numbers are always increasing by 1. So there's our constant pattern there. And our number of matchsticks seem to always be increasing by 4. So +4, +4, +4. So we can go back and we can do 22 plus 4 is 26, +4 is 30, +4 is 34. Then we got 38 and 42. All right. Oh, I actually realized we just didn't go back up here and do 50. So let's do this one and we'll go back up here and finish that first one. Okay, so this is going to be number of matchsticks equals shape number times, this will be our constant increase, and it's always increasing by 4. All right, plus our starting point, which our starting point we need to know figure 0 for. All right, so if we had a number +4 will give us 6. What number +4 gives us 6? That'll be 2. So our starting point is 2. Let's use this formula to get the 50th. So it would be 50 times 4. 50 times 4 is 200. And then 200 plus 2 will be 202. Real quick, let's go back up here. We're going to use this formula. So shape number is 50 times 3. That's 150. Plus 1 is 151. Sorry about that. All right, looking at number 3. Figure number is always jumping by 1. Just always got to check that just in case. And matchstick number seems to always be increasing by 2. So let's fill this out. We'll go 13, 15, 17, 19, 21. All right, so it's going to be shape number times 2, because that is our constant increase, otherwise known as our rate of change or our slope. We need to find our starting point, so we go to figure 0. What number +2 is going to give us 3? Well, that'll be 1, so our starting point is 1. Now we can use this formula to find how many for 50. So 50 times 2 is 100, plus 1 is 101. And the fourth question, or part D, figure number always is increasing by 1, just like our past problems here. And it looks like number of matchsticks is always increasing by 3. All right, so we go 17 plus 3 is 20, plus 3 is 23, plus 3 is 26, 29, 32. All right, so our constant increase is 3, so shape number times 3. We need to know our starting point, so we have to find figure 0. Something plus 3 is going to give us 5. That'll be 2. That'll help keep our pattern constant of plus 3. So the starting point is 2. To find 50, we just plug in 50 right here. So 50 times 3 is 150, plus 2 is 152. All right, on to the back side. We kind of have a couple of things going on here. We kind of have multiple different patterns. So it says, Gia started to make a sequence out of star and pentagon blocks and recorded her findings in the table as she went. She had to stop when she ran out of pentagons. This is where she got up to. Okay, so we have figure number 1, figure number 2, and figure number 3. Let's just make some observations. In figure number 1, we have 1 star. Figure number 2, we have 2 stars. And figure number 3, we have 3 stars. So the number of stars is always matching the figure number. And you can also see that here. Okay, the number of stars always matches the figure number or the shape number. And it always just increases by 1. So we can fill the rest of this out. And we know that the 15th figure is going to have 15 stars. It's always the same amount. Same number of figure and same number of stars. All right, so then looking at pentagon, it always looks like we have 1 less than the figure number. So figure number 2 only has 1 pentagon. Figure 3 has 2, so it's always increasing by 1, but it's 1 less than the figure number. And we can see that here as well. So increasing by 1, but always 1 less than the figure number or also the star number. So 1 less than 15 would be 14. It gives us the formulas or the rules here. So to find the number of stars, you just do number of pentagons plus 1. To find pentagons, you do number of stars minus 1. So how many stars are in the 10th shape? Well, stars always matches figure number, so 10. And we can even see evidence of that right here. How many pentagons are in the 15th shape? Well, there's always 1 fewer pentagon than shape number, so there should be 14. Okay, last one. Tyson also made a sequence out of pattern blocks, but stopped after the first 3 shapes and decided to continue investigating by using a table. Okay, so let's make some observations. This is figure 1, figure 2, figure 3, and I'm noticing a similar pattern. We have the same number of crosses as figure number, and you can see that here. Figure number 1, 1 cross, 2, 2 crosses, 3, 3 crosses, and it's always increasing by 1, so we can fill the rest of this out. Okay, and then the number of rectangles, it looks like it's skipping by 2 every time, so we can just keep going with that pattern. Now that skipping by 2 makes it a bit more complicated when it comes to the rule. So if I wanted to find the number of crosses, these things right here, what I need to do is 2 plus the number of rectangles, okay? And then I take that number and I divide it by 2, okay? Remember that the number of crosses always matches the figure number. So we could even do figure number is the same way. We can calculate it the same way because they are the same number. Okay, number of rectangles is always 2 times the number of crosses. Well, the number of crosses is also the same as the figure number. So we could even do 2 times the figure number minus 2 if we didn't know the number of crosses. Okay, so how many rectangles will there be in the 12th shape? Well, that will be figure number 12. And if I wanted to find rectangles, I can do 2 times the figure number, that's 12. Okay, so we can do 2 times 12, which is 24, minus 2. That'll be 22. All right, Josie made this shape following Tyson's sequence. What is the position of this shape? That just means what's the figure number? Remember that figure number always matches the shape number. So if we can just I'm sorry, figure number matches the number of crosses. So if we can just count the number of crosses, it'll tell us what figure number it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 crosses, which means it is figure number 9. And I will leave that how do you know section for yourself, because you're going to answer that in your own words. But something to the effect of, you know, we could even do a formula here, but we know that the number of crosses always matches the position, the figure number. So we just counted. Okay? All right, and that is lesson 4 of Unit 5. Bye, guys.